Okay, so our last video was on introducing the idea of what a conditional statement, an if-then statement, and its converse is. Largely overall in Chapter 2, we're just continuing to introduce some vocabulary to you that we're going to use all year in geometry, more vocabulary like vertical angles, linear pairs. So if you feel like you are iffy on some of the vocabulary that we've learned so far in Chapter 1, it may be worth you just kind of reviewing that on your own. We're going to introduce some more in this section. This is a quick section, but we're also going to continue our conversation about and our discussion about writing down statements and different types of statements. So the first definition that we're going to introduce, and you can add this to your definition sheet, so if you need to pause the video in order to get it on your definition sheet, you can do that now. That's perpendicular lines. Okay, and this is you've probably heard about perpendicular lines before. It's probably not a new idea, but we're going to explicitly define it, and here's how we're going to define it. Two lines are called perpendicular if they intersect to form a right angle. Okay, so just in the definition, we have a couple qualifications. One is that there are two lines, they're intersecting, and their intersection forms a right angle. What does that mean? That means when they intersect, there is a right angle that is formed, and that's signified by this little box right here. That signifies a right angle, and of course we know that a right angle is equal to 90 degrees, but two lines that intersect to form a right angle are defined as a specific type of intersection, and that type of intersection is perpendicular. Okay, so that is perpendicular lines. If we wrote this definition in if-then form, it would look like this. If two lines intersect to form a right angle, then they are perpendicular. That would be if two lines intersect to form a right angle, then they are perpendicular. So think for a second, what would the converse be? Remember, the converse is when I switch the hypothesis and the conclusion, so I switch the if and the then. So the converse of this statement would be if two lines are perpendicular, then they intersect to form a right angle. And those, of course, those things are both true. Remember, with definitions, we learned in the last section that definitions are true both forwards and backwards. So if two lines intersect to form a right angle, then they are perpendicular. Because this is a definition, if I reorder it and I write the converse, both of those will be true. Okay, and we actually have a special name for those types of statements that are true forwards and backwards, and those are called biconditional statements. Okay, a biconditional statement is a conditional statement that contains the phrase if and only if, and we'll get to that in a second. So we don't just say if then, we actually add to it and we say if and only if. Writing a biconditional statement is equivalent to writing a conditional statement and its converse. So when we write a biconditional, we're including the conditional statement and its converse all in one statement. And like I said earlier, biconditionals are true forwards and backwards. Two lines are perpendicular if and only if, there it is, not just if one thing is true, but only if this is true. Two lines are perpendicular if and only if they intersect to form a right angle. So in that case, if biconditionals are true forwards and backwards, what have we learned? What things have we learned that are biconditionals, that we could add this if and only if? Think about that for just a second. Pause the video and think about what things we have learned that are biconditional statements. Well, if biconditionals are true forwards and backwards, then we have also learned some other things that are true forwards and backwards, and that would be all of our definitions. All of our definitions are true both forwards and backwards. I want you to look at your theorems in your postulate sheet for just a second and see if there are any theorems or postulates that we have learned that are true both forwards and backwards. Those would also qualify as biconditionals. We could write them as an if and only if statement. Okay? So continuing right along, we're going to practice writing some biconditional statements. I'm going to show you a statement, and what I want you to do is I want you to rewrite this biconditional as two separate statements, one being the conditional statement and another statement being its converse. So you're going to take a biconditional statement that I'm going to show you, and I want you to rewrite it as two statements, a conditional statement and its converse, okay? So when I show you this, it probably would be helpful for you to pause the video so that you can get the statement down in your notes, then take some time to try and write it as its conditional and its converse before you play the video, because I will actually be showing you the answer here in the video. So, two angles are supplementary if and only if their sum is 180. That is the definition of supplementary angles. So what I want you to do is I want you to pause the video, write this in your notes, write what the conditional statement would be and what the converse of that statement would be, and when you play the video, I will show you the answer. Okay, so hopefully you have the conditional statement and its converse in your notes. The conditional statement would look like this. If two angles are supplementary, then their sum is 180. We saw that in the last section. And then the converse of that would be if I flip-flopped these two statements. So the converse would be if two angles' sum is 180, then they are supplementary. So that is taking a biconditional statement, this biconditional statement that we have right here, and rewriting it as two statements, the conditional and its converse, okay? So this time, I want you to rewrite this conditional. I'm going to show you a conditional statement and its converse, and I want you to rewrite it as a biconditional. Here are the two statements. If an angle is less than 90 degrees, then it is acute. If an angle is acute, then it is less than 90 degrees. Once again, this is the definition of an acute angle right here. So this is a definition which we know are true forward and backwards. What I want you to do is I want you to pause the video, write these two statements in your notes, and then take some time to try and write the biconditional statement. Remember, the biconditional is the if and only if statement. Okay, so now you should have that biconditional down in your notes, and I will show you now what the biconditional statement would be. The biconditional version of these two statements, the conditional and its converse that are both true, would be an angle is acute if and only if it is less than 90 degrees. There's only one qualification that makes an angle acute, and that is that its measure is less than 90 degrees. So that must be true in order for it to be acute. So there you have it. That is it for section 2. Like I said, it's a short section. I will be putting there are practice problems on PowerSchool that you will need to do and show me for their correctness. And then we will continue on. We will skip section 3 and go straight into section 4.